Hello, my name is Richard Rabin, the Product Marketing Manager for Abby Timeline, and the topic for today's talk is process intelligence and its synergies with robotic process automation. So first, let's talk about process intelligence and particularly how that compares to, for instance, process mining that many people are familiar with. So when we talk about process intelligence, we're talking about something that starts with process mining but adds more capabilities on top of that. So it would include process mining as well as task mining. And we'll talk about all of these in more detail in just a moment. But in addition to process and task mining, there's also added analysis and optimization options off of what you would typically expect in a pure process mining solution. And this becomes important for the work that we want to do with RPA. And additionally, once we've got process and task mining, we've got a series of analysis options on top of that. We also, in process intelligence, have the ability to do operational monitoring and compliance monitoring. So we're going to be watching each event as it happens for each instance of a process and comparing that against process rules so that we can see if there are any compliance rules or other operational rules that are violated. And finally, with process intelligence, we also have the ability to do predictive analytics, and I'll talk about what that is and why that would be important also for working with robotic process automation. So let's just start with process mining, with the core of process mining. The fundamental idea of process mining is that in today's modern business systems, virtually any system you're working with is going to be keeping a record of the transactions within the system, so that these transactions will be available for later analysis. And these record of transactions will almost always include, and the same fields are used by all process mining tools, we need to know what event occurred, when it occurred, and each event has to have some kind of a unique process identifier, something that allows us to group all of the events that go with a given process instance. So if you're processing documents, it might be a document ID. If you're dealing with insurance claims, it could be a claim ID. Or in a hospital, it might be a patient encounter number. But one of the key facts of this is that typically you have multiple systems of record that you're going to be working with, and these different systems of record may or may not have some ability to visualize what's happening in terms of the various process instances that are executing. But what we have found is that in almost all cases, most of the processes of interest to our customers end up spanning multiple systems of record. So even if your CRM system or any of your other major systems has tools for allowing you to visualize what's going on and analyze what's going on in that system, they won't have tools that allow you to look at the entire business process as it is distributed and spans multiple systems of records. So with process mining and process intelligence, the idea is that we're going to pull these data artifacts, these indicators of what steps happened and when. We're going to pull them from all of the systems of record and databases, and that allows us to then recreate what happened in your process, in your distributed process within one model, sometimes referred to as a process digital twin. Now, some of the people in the past when I've talked about this topic have asked, well, if I've already got all of the data that you're talking about in my databases, and I've already gathered all the database information into a repository, and I might have already set up a business intelligence platform over that repository or data warehouse, if I've already got all my data in one place and I've got tools that are structured to analyze data, why do I need process mining or process intelligence? And the reason is really very simple. The reason is that databases and business intelligence tools aren't set up to be able to reason over processes. They don't have tools for visualizing processes, and they don't have tools for reasoning over processes from the standpoint of, if you're looking at a process instance, well, did some behavior occur in that instance or not? The things that you might care about, for instance, for monitoring or for looking for exception cases, sure, you could create SQL queries to look for some of this information, but by the time you look at what events are included and skipped and repeated, the sequence of events, the attribute values of events, all the things that would go into a process behavior, turns out that trying to do that in a query, writing the query in text becomes very difficult, and maintaining a complex set of multiple queries becomes very, very difficult. So with process intelligence, you have the ability to easily graphically visualize your process and also to reason about the process in multiple ways. And we'll talk about that in just a moment. So the next piece here would be when we talk about process intelligence, it often brings together these days process and task mining. And why is that? Well, I've been working with process mining for over 10 years now, really process intelligence for over 10 years now. And in the early days, when someone pointed out that some of the steps they cared about didn't leave any records in any of their log files, they might be something such as a person used the web to go out and look for information. They then copied it and pasted it into a spreadsheet. They then might have created an email that included that spreadsheet. Well, those steps don't work well with process mining because they don't leave behind the kind of information that process mining relies on. But they do work very well for task mining. And that's the difference today versus when I was asked this question a decade ago, is that back then the answer was simply, we don't have the ability to record these things, to analyze these things if there are no log files created. Well, now with task mining, we do very specifically have tools for recording what's done in these manual tasks that someone might do on a desktop that aren't leaving these kind of digital breadcrumbs. So for instance, when you're looking at process mining working together with task mining, on the left, we're representing process mining with your various systems of record that you might be pulling the data artifacts from to tell you what automated recorded steps happened and when, whereas on the right, we're referring to the task mining piece of this. So where there's a gap in the process mining information because no data was recorded on certain steps, we can now specifically record those steps as they're manually done. Now you'll notice in this picture on the right that refers to task mining, you see multiple different desktops. And it's worth noting that when you're going to gather this information from task mining, both to overall analyze what's going on in these manual steps, and as we'll see, to use with RPA, one approach to that is to install a single recorder on a single desktop, put it in the hands of a user who knows the process very well, and record what would sometimes be called the happy path. So record exactly what you would expect to happen in a well-formed instance or case. The problem with that is that if you really want to understand what's happening in your organization, what you're likely to find is that you have different people with different levels of training who are going to do the task differently. You've got different types of instances of a task that require different forms. So that one way to deal with that would be to install not one recorder on one user's desktop, but install a set of recorders across multiple users' desktops so that I can get a sample of how this kind of work is done across different types of users. And another point worth making is that this diagram shows you another server between the recorders and the task mining environment. Well, the reason for that is if you're going to be recording users doing these tasks, you don't want to put a lot of computational effort on their systems to slow down what they're doing and mean they can't do their job normally. So we typically would offload tasks such as obfuscating data to a recording server so that the recording server does the heavyweight lifting and just passes the log files that include records of what manual steps have been done. That gets passed into the task mining environment from which we can then pull out the significant tasks and use that for analyzing what's been going on. And as you'll see, also use it to help design automation for that in your RPA environment. Now, also when you're looking at task mining versus process mining, it's worth note that one of the key differences is that there are different types of analysis typically when you're talking about process mining and process intelligence. And this has a bearing on what you need to be able to design your RPA automation. So for instance, in process mining, we typically rely very heavily on this type of a schema diagram that takes all of the process instances, each case, and maps them into one particular diagram that can show you the flow of steps in your process. Now, this has been very, very useful in many situations for people to understand what's happening, and there's a lot more than you can see in this diagram. It's typically annotated with how long steps took or how many times you followed one path versus another. It includes forms of animation to let you see what the flow looks like. But the fundamental limitation of this approach is that when a process is as simple as visualized here, looks great on such a diagram, but as the process starts getting more complicated with more nodes or with more options, so that there are more lines interconnecting the nodes, and it looks more like a spaghetti diagram from old coding days, then what has to happen to make the schema diagram more usable is that all the tools I've seen start giving you options to filter out the less frequently used cases, which may be fine if you want to see what happens in general in the flow of your information. But if you're really looking to try and automate steps, then some of the exception cases that you would have to filter out to make this kind of a diagram understandable, well, they end up being important and you wouldn't want to filter them out. So when you look at process intelligence as compared to process mining, one of the big differences with process intelligence is that there's a lot more focus on various types of numerical analysis outside of this kind of a schema diagram, as well as a focus on each individual case and reasoning about each individual case. So just very briefly, you might have things like this path diagram where each column represents a path through your process. So that, for instance, the most common path would typically be on the left, and you can't see the details, but you might see at the top there metrics, so that you can see how often each of these different paths is followed, how much time it takes when you do the task one way versus when you do it another way, or even what the cost is. So various ways you can help to rank order and understand the different options you have for how a given task is done. And then with process intelligence, you have many more displays, whether it's a graph showing you how frequently you do a task very quickly versus how often it's done very slowly, whereas in this case, almost all the tasks is done very quickly, and those that take longer are very, very rare. And you also have the ability to do additional analysis, such as if this is showing me how long from step A to step, let's say D, because they don't have to be right next to each other, and a histogram essentially showing me the distribution of values for how long that takes. I can also do dimensional analysis. Now, you can't see much of the charts in the bottom, but you probably can see that they differ. Some have spikes where others don't. So what we're really seeing here is when you take the same time to do a particular transition of interest and break it down by operator, you can get some root cause information. You can start to see who is taking longer and what the patterns are. Now here I say who based on operator, but the dimension might be something completely different than operator. It might be shift, it might be location, various ways you can look at it. And there are many other types of analyses which are included with process intelligence, and we'll talk more about the relevant ones of those in just a moment. Another difference between process mining and process intelligence is that process intelligence typically has more of a focus on each individual case, whereas process mining, you're largely taking a large data set and mapping it to a diagram like that schema diagram and generating various metrics, but you're not necessarily following all of the data from each case. Whereas in process intelligence, yes, we are keeping all of the data from every case that allows us to define various process behaviors, and we can then scan for where those behaviors occur, which might represent inefficiencies or might even represent cases where we've violated various compliance rules that we're responsible for. And with process intelligence, we can then send out a notification when it's detected that one of these rules is triggered, or we can even call a bot, a digital worker, or any other web service really, but we can call a bot to take action. So when a given situation is found, you can utilize your electronic workforce, your digital workforce, by automatically kicking off a bot to remediate a given problem that we might have seen. One other thing I'll point out that you have as an opportunity with process intelligence is you start out with the fact that we've got this digital twin, this model of your process based on the actual data from multiple distributed systems. Supporting the monitoring that we just talked about was the idea that this information is coming in real time or sometimes near real time, but the information is coming in continuously and keeping this model up to date. Well, if we've got a model of your process, we've got up-to-date information on that. Another opportunity is to use predictive analytics. We can have a neural network that's trained to recognize the common process behaviors so that as new process instances are occurring, it can look for patterns that imply the likelihood of certain behaviors. And the tool that I'm used to, this would be things such as being able to predict whether a given service level agreement, a given deadline will be made or missed. Now, of course, with monitoring, you can always wait until a deadline is missed, observe the deadline is missed, and report on that or act on that. But with predictive analytics, you can predict that it's likely that a deadline will be missed based on historical cases and act on that. And in our case, it's not just if a deadline will be missed, an SLA will be missed. It would also be able to predict things such as if a process has multiple outcomes, I can then at any time while the process is executing tell you, based on the neural network trained against other executions of this process, what is the likelihood, based on what we've seen so far in a given process instance, what is the likelihood that we will have one outcome versus another? So that's the ability to use predictive analytics as a part of process intelligence. So now how does this all relate back to supporting RPA? We're going to look at this in terms of process discovery, automation design, process monitoring, and benchmarking. In the area of process discovery, one of the things that's critical is you don't want to automate a process until you fully understand it. I've heard from many different clients that there's a problem when they try and automate a process that's not well understood, that you can take what's essentially a broken process and make it just run faster. You really need to get a view of what is happening within your process, either by looking at start to end how it takes, or any significant transition within your process to understand where time is being spent. And once you understand where time is being spent, then the ability to automate a given manual task becomes much more useful, because you may otherwise automate a manual task only to find that it makes no real difference in the overall speed of your process, because maybe it's just moving where the bottleneck is from one place to another. So by understanding your process and where time is spent, you can get a better understanding of where automation is going to help you. And beyond that, process intelligence with its task mining capabilities will also help you find automation candidates. So after you have run those recorders that were previously referenced, you'll have a log of the steps that were done by the individuals who are doing these manual tasks. The system can then, both using automated tools as well as manual intervention, can find the tasks within the log file. So it can cut up the overall files that show what steps people are doing into what are the different tasks that are being done by these individuals. Once we have a list of what the different manual tasks are, and we know some information about how each of those tasks is being done, we are then able to rank what are the best automation candidates. This becomes critical for RPA because many of the easy instances, the low-hanging fruit of what would be good to automate, have already been done. So this allows you to look at other tasks being done by various people in your organization and measure how often are they done, how long is it taking, and also a variety of attributes that will help you determine how difficult these would be to automate. And once you've done this discovery, a byproduct of discovering these tasks is I can use these task outlines that have been recorded to help generating an implementation skeleton to make it easier to build the actual bot. Now we talk about ordering, ranking these automation candidates. Here's one example of how that might be done. So if I have a log file that I've recorded from many users throughout the day of what activities they're working on, and for each user's log file, I can identify tasks by repeatable sets of actions that might represent an expense report or filling out a registration form or various other tasks. So we've gone from a set of users who are working at their systems to a log file of activities to a list of the tasks that are found in those activities, and each task has various analytics done against it. So it might be, how many times did I generate this expense report? Or what percentage of the log of recorded steps were involved with generating expense reports? On average, how many events, how many actions were involved in one of those tasks? Or what is the overall complexity? Now, when we talk about complexity, there are various ways to measure complexity. What we're really looking for is how difficult would this task be to automate? And complexity might include how many variations there are of this task. If to do this task, it's always done identically, that would be relatively easy to automate. But if it turns out there are many different options based on the different options for an expense report, then it might be that that's more complex. And we're also measuring the number of applications that are used within each task. And some people might even have a ranking of which applications are more easy or more difficult to automate the steps for. So in other words, we're able to gather data for each of these manual tasks on both how complex will it be to automate and what is the potential gain. If I know how often it's done and I know how many events it has, I can look for things like how difficult it will be to automate this, as well as what the likely gain will be by time saved by automating this. So if I then take the various tasks that are discovered and I put them on a graph that shows both which ones show the most potential gain and which ones are likely to be the hardest to automate, I can then assist in picking the best automation candidates by looking for those that have the highest gain with the lowest complexity as being potentially good candidates for automation. So rather than just relying on someone's guess as to what they think would be the right task to automate, you actually have hard data that allows you to make such choices. So the next would be automation design. So once I already have recorded these manual tasks and I've done some analysis to try and understand which ones offer the most promise as far as automation candidates, well, then I have to design the underlying bot itself. With process intelligence and with its use of task mining, I can actually see what are the different ways a given task is automated, pick the ones that are of interest to me and build those into a bot. And I can then take that definition of what the steps are and directly export it to an RPA tool that can generate the skeleton of my bot from that. We're not to the point yet where you can just pick the task you want to automate and have the bot generated for you automatically. But what we can do, now this is actually a diagram, a path diagram from process mining, but we also have these path diagrams from task mining where each step would be one low-level action or one form interacted with. And you can see for a given task, what are the steps, how much variation is there based on one type or another, how long did it take when you did it, how frequently did you do one of these variants versus another. And at least in the tool that I'm used to, after analyzing the different ways that a task might be done, you can click to select which of these are important to you and then export that into an RPA tool, such as in our case, we're working very closely with Blue Prism, such that Blue Prism will get the definition of whatever paths I have said I'm interested in and can use that definition to generate the skeleton of the bot that will have to then automate these multiple different options of the way this type of task is done. But rather than starting from scratch, you can take a look at a recording of the different ways that a task is done, select the ones of interest, and use that as the core of the bot being implemented. There's also an important aspect of monitoring when you're looking at process intelligence working with RPA. And it's important to note here that when we talk about monitoring, we're not just talking about monitoring the bot performance. Certainly an RPA tool is likely to give you information on how many times a bot has run, what the statuses were, how long it took. But if you really care about understanding the behavior of your system, you don't want to look just at a set of bots by themselves. You want to look at the entire system performance so that you can understand if you automate a particular manual process, how does that affect the flow of the overall larger system? So it's important to be able to look at the distributed end-to-end process. And once again, what we see is that these processes, part of it might take place under the control of a bot that was created, part of it might take place within other systems of record. So that if you want to monitor the performance of the larger system, you can't do it from just the RPA tool. You can't do it from just some other system of record. You need something analysts sometimes refer to as a control plane, something that sits outside of the normal systems that are executing this process, but can monitor all these systems. And that's what you can do with process intelligence. And now a part of that, of course, is to validate that the automations you're building are giving you the benefits you expect, so that when you plug in a new RPA bot, you want to understand not just that that bot is saving 95% of the time to do that manual task, but does it make a difference to the overall larger process that that bot is a part of? Sure, it might save all the time that is saved by automating that system, but if there are bottlenecks downstream, it might not make the difference that you're hoping for. So being able to monitor the entire distributed system allows you to validate that any automations that you're creating are giving the benefits to the overall process that you would expect. And when you're doing this kind of work, it allows you to monitor not just the traditional system metrics, things like how many times did I run a particular process instance or how long did it take, but any metric that relates to that process instance is also available to use as part of this monitoring. And I'll talk about that in just a moment. And then there's also the compliance, as was discussed, the ability to monitor how many times these alerts or rules were triggered. Now, when I talk about behaviors and monitoring behaviors to see how often I might have triggered some compliance check, well, there's many ways in process intelligence that you can define behaviors. I will just show you a few examples here, but what it boils down to is what events are included, what events are skipped, what events might be repeated, the sequencing events, the timing between the events, all of these things that are important to understand process behavior, but aren't necessarily easily handled by a database or a BI framework. So in this case, we might look for any patients that arrived on Sunday, and we got a record of a lab result. As a matter of fact, we got 2 of them, but we have no record of labs being ordered. And then after the lab result, we have a record of the patient being admitted, and it took more than 30 minutes from the time we got our results to the time the patient was admitted. So that would be a sample behavior. Another might be anytime a performance review was done, and the next performance review took more than 6 months. We might want to note that as something that shouldn't have happened. Or another simple example is anytime we did any of these insurance steps, claim closed, denied, filed, claim in process, did we do any of these steps with having no coverage confirmation before those steps were done? So just a few examples of what a process behavior might look like. And now when you're talking about benchmarking using process intelligence and RPA, well, that's when these behaviors become interesting, because clearly you can do benchmarking of your system that you're applying some automation to compare, say, week over week or month over month. Or after you've implemented a bot, you might want to compare before and after you have implemented that bot to better understand the true benefit from that automation. But you can also break it down by process behavior. You're also able, with these process behaviors, as we described a moment ago, to be able to use that as an analytic dimension. Show me what my results look like when I do the process one way versus I do it another way. And as far as what metrics are we talking about? Well, if you're looking at something like credit card onboarding, you might have a number of times that a new card has been activated. Another count metric would be the number of credit card applications. Well, by creating a derived metric by dividing these two, I end up with the percent activated. This becomes important because when you're looking at the overall process behavior or looking at the process metrics, you might want to say, based on how we did the process, based on what behavior was executed, does that make a difference in the percent of cards that were activated? Or if you're talking about data from a hospital, for instance, well, you might have the basic data as to what steps were done, such as patient arrived in the emergency department, but you can use database joins to take studies that were done after the fact, but still have a reference to the patient ID number, where you might have done a survey on patient outcomes. You might have created a score that rates patient outcomes, or you could have done it in terms of patient satisfaction, or in other retail, it might be customer satisfaction. But the basic point is that if you have access to data like a customer satisfaction value or an outcome value, you can generate an average metric, and now I've got average patient outcome. What does that buy you? Well, keep in mind here, we're talking about using this with a process in which we're using RPA. This would actually work with any process, whether you're using RPA or not. But what allows me to do is to define a behavior such as standard protocol, which in our case might determine how long is allowed between certain steps, what steps must be done. And I can then have the system go back and characterize, take all of the process instances that followed the current protocol and show me the metrics such as the average number of events, the average time, or the average patient outcome. And I can see when I followed the standard protocol, I can see what the timings were and I can see what the outcome is. But then I can also define an expedited protocol. It might involve shorter timings or more checks that need to be made. Again, it would be a different set of process behavior rules. And I don't have to set up all these rules and tell people to go collect data again. Instead, I have the process intelligence framework, look at the system for which I'm collecting data, and isolate all those instances that followed the current set or the standard protocol, and also isolate all instances that follow the expedited protocol. Even if that's not what's required these days, some of the people working here do follow those protocols, and that way, without doing multiple tests, I'm able to slice and dice my results based on what behaviors were followed. And I can see that with the standard protocol versus the expedited, well, actually the expedited protocol took more steps, took more time, but the patient outcome was substantially better when following the new protocol. This means that any user can come up with ideas on any different behaviors they think should be followed. And then even after the data has all been collected, define these new behaviors or protocols, and then be able to compare what your results look like when you did it the old way versus did it the new way. Same thing if you're looking for something like a credit card onboarding example. I've got my current guidelines and I see what the time and the counts and the percent activated, the metric we saw a little while ago, are. And I can see here that when we follow the new guidelines, I can see that my percent activated is about 10% higher. So in other words, when you're using process intelligence, you can define behaviors. You can use those behaviors for monitoring and alerting. You can use those behaviors for various types of reporting. You can also use those behaviors and analytic dimensions to show when I do my process one way, what are my results? When I do my process a different way, what are the results? But taken all together, what you'll see is that when you're looking at process intelligence, working with RPA, another way to look at this is that it allows you to understand your process by visualizing it and annotating it with various metrics. It allows you to understand aspects of how your process is performing, not just what are the steps, but how it's performing. What are the variations? What's the difference in cost or time when you do it in different ways? You can then define behaviors that can be used for monitoring, alerting, and even used as dimensions to slice and dice the data based on how a process was done. And finally, you can add things like predictive intelligence, things like predicting whether you will or will not make a particular deadline so that you can act on these things and prevent a problem before it actually becomes a problem. So I want to thank you for your time today. Overall, what we've tried to cover would be what is process intelligence and how can the capabilities of process intelligence make a difference with your RPA environment, both by allowing you to set up automation faster by understanding what you're doing and building the skeleton of the automation in a semi-automated fashion, as well as being able to then analyze the results when you do these changes through automation to see how it affects the overall process outcomes. Thank you very much. And if anyone would like to contact me to discuss these further, I'd be more than happy to speak to you. Thank you.
Wow. Thanks, Richard. Hey, thanks, Richard. Sorry about that. Fun of the joys of camera. Some great insights there. I thought they built so much nicely. And you know what it's like when you watch these things and you listen to people and think, John, I wish I'd said that. I wish I'd covered that. And so some of the things that I think really built for Richard on what I was talking about earlier were reminding us that those processes span multiple systems, reminding us that BI and process intelligence, while being related, are not the same. And I thought there was some really nice stuff there in terms of how we talk about connecting the process mining with the task mining. So once again, thanks, Richard. Great job, great insights, and hopefully everyone is going to get some back. So I'm going to say thank you to Richard once again. We're going to be joining you on the top of the hour. Slight change to the program. We're going to have Blueprint Systems coming up next. So time for us to refresh those coffee cups, and we'll be back in just a few minutes. Great. Thanks, everyone.